Industries, Part 1. In this module, you will learn about the types of industries on the basis of raw materials, size, and production processes. Industries can be generally classified into different types on the basis of raw materials, location, size, production, process, the nature of work, and ownership of the industry. Based on the type of raw materials used, industries can be classified into forest-based industry, agro-based industry, and mineral-based industry. In forest-based industries, the raw materials are obtained from the forests. Examples of such industries include paper industry and furniture making. Agro-based industries use raw materials obtained from agriculture to produce new products like cotton textiles, jute products, and sugar. The raw materials for mineral-based industries are mineral ores. Examples of such industries are iron and steel, cement, aluminium, and chemicals. Based on the scale of operations, industries are divided into large-scale industries, medium-scale industries, small-scale industries, and cottage industry. Large-scale industries are large establishments. Large-scale industries involve huge investment, the use of heavy machinery, and the employment of a large number of workers. For example, Integral Coach Factory, Chennai, Tata Iron and Steel, Jamshedpur, Bharat Heavy Electricals Limited, also known as BHEL, in Trichy, and Steel Authority of India Limited, also known as SAIL in Salem. Medium-sized industries are medium in size and invested and are technology-oriented. Example, computer industry and electronic industry. Small-scale industries are small establishments with small investments and small labor force. It may involve domestic production, for example, hosiery, hand tools, and stationery items. Cottage industries are very small in size with low investment. They are usually family or small group based. Examples of such industries include handloom, mat weaving, bamboo, cane products, and pottery. Based on the process involved in production, industries are categorized into heavy industry and light industry. Heavy industries use bulky raw materials and produce large and heavy products. They are capital and resource intensive industries and involve large-scale manufacturing. For example, iron and steel industry, Tisco, heavy electricals, BHEL, and automobile industry, Ashok Leyland. Both raw materials and finished products are light in weight in light industries. They are less capital intensive and consumer oriented. Industries which manufacture hosiery, watch industry, and household goods can be classified as light industries. Industries can be generally classified into different types on the basis of raw materials, location, size, production, process, the nature of work, and ownership of the industry. Based on the type of raw materials used, industries can be classified into forest-based industry, agro-based industry, and mineral-based industry. In forest-based industries, the raw materials are obtained from the forests. Agro-based industries use raw materials obtained from agriculture to produce new products like cotton textiles, jute products, and sugar. The raw materials for mineral-based industries are mineral ores. Based on the scale of operations, industries are divided into large-scale industries, medium-scale industries, small-scale industries, and cottage industry. Medium-sized industries are medium in size and investment and are technology-oriented. Small-scale industries are small establishments with small investments and small labor force. Cottage industries are very small in size with low investment. Based on the process involved in production, industries are categorized into heavy industry and light industry.
Welcome to GP Corrugated, where we manufacture and sell corrugated sheets, standard corrugated containers, and a variety of specialty packaging products. Today, we'd like to show you how we make our products.
The beginning of all corrugated packaging is corrugated board. A series of sophisticated machines acting in unison to create the corrugated board is called a corrugator. The raw material of corrugated board are the container board grades of paper. Liner, which becomes the flat facings of the board, is primarily made from the long fibers of softwood trees. Medium, which becomes the fluted middle layer of corrugated board, is made primarily from shorter fibers from hardwood trees. The first step in making corrugated board occurs in a machine called a single facer. A single facer combines a liner and a medium to form a single face web. To do this, the medium passes through a set of corrugating rolls under high heat and pressure to form the flutes that give corrugated board its strength and cushioning capability. Each set of corrugating rolls are made in specific flute profiles to create the performance attributes needed for the finished packaging item. A pressure roll loads the correct pressure and also brings the liner into contact with fluted medium after a cornstarch-based adhesive is applied to the flute tips by the glue roll. The glue roll turns against a metering roll to control the proper amount of adhesive that is delivered to the flute tips. It is critical that the correct pressure is applied to the corrugating rolls and that the adhesive reaches the proper temperature and consistency to form a strong bond between the liner and fluted medium. This combination is called the single face web. The single face web then leaves the single facer and is elevated to a bridge that carries the web to the double glue unit and the double backer. The liner and corrugated medium are fed into the single facer from opposite sides via a pair of roll stands for each. They are connected by a device known as a splicer. The splicer allows for changing from one roll to another without stopping the machine when the roll is consumed or when a change in paper grade or width is required. As roll stock is unwound and heads to the single facer, the paper passes around heated rolls or preheaters that bring the paper to the proper temperature for the corrugating process. Wrap arms control the amount of time that the paper is exposed to the heat, enabling a degree of control in increasing or reducing heat to the paper. The single face web is carried up and away from the single facer by incline belts. The web folds up in festoons for the length of the bridge until it enters the E&L section of the bridge that leads to the triple stack. This allows the single face web to cure with a firm bond, so the integrity of the flute structure is not disturbed. If double wallboard is being made, both of the corrugator's single facers are running and delivering two single face webs to the bridge to be combined at the double glue unit. The single face web is threaded through heated rolls and into a machine called the double glue unit that applies the cornstarch-based adhesive to the flute tips. The liner that will become the outside facing of the corrugated board is threaded through the heated rolls on the bottom of the triple stack. The outside or double face liner is joined to the single face web as the board is pulled into the double backer. The double backer generally has a top and bottom belt that pulls the board through the machine. The double backer has a series of heated plates that continue to transfer heat into the board to cure the adhesive bond. It is the belts in the double backer that pull the board through the wet end of the corrugator and push it to the dry end, where the combined board is scored, slit, and cut to finished specifications. After the board goes through the double backer, it passes through a shear that severs the board to permit order changes and then into a slitter score. The slitter score slits the board into the proper width and, if needed, places the scores into the board to the specific dimensions. The state-of-the-art slitter score, shown here, has two separate slitter score sections. One section is setting up for the next order, while the other is running. When it is time to change orders, the shear severs the board to create a small gap to allow the slitter score sections to either drop in or rise from the board pad, so the board can align between the top and bottom shafts that the scoring and slitting heads are mounted on. This feature allows order changes to occur at line speed. After the board is slit and scored, it continues to the cutoff knife. The cutoff knife cuts to the precise dimensions requested of the finished corrugated sheet. Most corrugators have an upper and lower knife, so that two different orders can be combined to run in the same width and grade of paper. There are exit rolls that eject the cut sheets onto belts that shingle the sheets to the stacker bays. The stacker beds of the corrugator accumulate the sheets into stacks, which are then discharged on moving belts for the stacker operators to perform quality checks and prepare for strapping and shipment. Converting machines turn corrugated sheets into boxes. These machines print designs and branding onto the boxes and cut the boxes into the proper dimensions for their need. There are two main types of machines: rotary die cutters and flexo folder gluers. The flexo machine glues and folds the box upon completion, while the rotary die cutter leaves the box unglued and flat. Rotary die cut boxes are typically formed by hand, such as pizza boxes, or wrapped around a product and joined on a customer's equipment. A rotary die cutter also has the ability to produce multiple boxes from each sheet, whereas a flexo machine yields one box for every sheet. Through a series of lasers and optical sensors called photo eyes and communication between an inventory management system and real-time production scheduling, material is transferred to each machine center onto an in-feed conveyor. Automatic transfer carts keep each machine fed with corrugated sheet stock. Each stack is broken down into smaller sections, called blocks, and shingled individually to a feed table. The sheets are fed via a set of feed wheels that work in conjunction with feed rolls that insert the sheet in the machine. Feed rolls are made of a soft durometer material that prevents the board from being crushed. Maintaining board caliber or thickness is essential to providing overall board strength to the final box. A vacuum transfer system carries the sheet through the machine across multiple print sections. On a rotary die cutter machine, the designs and branding are printed on the bottom of the corrugated sheet stock. After the stock moves through the print section, it reaches the rotary die cutters. There are different cutters for every box type that the factory produces. The cutters are built from two half cylinders with metal blades embedded, as well as foam rubber sections to eject the cut board scrap pieces. Scrap is recaptured and recycled back to a paper mill to be used in future roll stock production. The next section is called the scrubber, which removes any remaining loose cutouts and any rough edges on the cut sheets. The sheets are then shingled again to slow down the speed in which they reach the stacker. If the cut sheets hit the stacker too hard, it will damage their edges. The stacker beds accumulate the sheets into stacks, which are then discharged on moving belts for the stacker operators to perform quality checks and prepare for strapping and shipment. The beginning of the flexo process is very similar to that of the rotary die cutter. Stock is fed into the conveyor by the automatic transfer carts. Each stack is broken down into blocks. In this flexo machine, the printing is done on the top of the sheet, so the stock must be inverted. The stock is transferred to a pre-feeder, where the stacks are inverted. This automation eliminates the need for manual inversion. The sheets are then shingled and loaded into a feed bed, where feed rolls insert the sheet in the machine. Print plates are mounted on a cylinder, and an ink system allows ink to be applied to the print plate, where it transfers the ink to the board as it passes through the machine. This machine uses rotary die cuts as well, but it only produces one box per sheet, unlike the rotary-only cutter, which can produce multiple boxes per sheet. The scrap is again recaptured and recycled for future roll stock. On a flexo machine, glue is applied in preparation for folding. After the glue is applied, boxes are carried through a folding section with vacuum-assisted belts and a series of folding rods, forcing the panels to fold in the proper sequence. The folded box is now glued and joined as it exits the machine and is stacked into bundles to the customer's specifications. Added compression time is given to allow the glue to fully cure. Depending on customer specifications, each bundle is strapped together to provide for stability in transit and ease in handling at the end user. To aid in the quality process, especially in high speed, a high-speed detection system called ClearVision is used to monitor glue placement and gap measurements on every box. A high-speed camera is placed at the point of glue application and can detect the amount and thickness of the glue lines, as well as the measurement of the slots in the front and back of each box. These measurements are compared to a developed standard that can predict whether a bad box will be produced as it travels through the machine. Any out-of-spec box that is detected will be sprayed with a UV coating, and the bottom of the bundle will also be sprayed. As the bundle travels down the conveyor system, a black light detects the UV coating and will eject the bundle so that an operator can locate the off-quality box and remove it prior to reaching the customer. To account for the speed of production, a doubler is used to assist crew members in combining each bundle in preparation for load forming. The doubler stacks bundles on top of each other. These combined bundles are then assembled into a specific stacking pattern to meet customer needs. Load tags are inserted into each unit to uniquely identify each load as it is sent to shipping to be made ready for delivery to the customer.
At the end of another workday, you can rest easy knowing that you have the very best corrugated supplier in the industry. Whether you need corrugated sheets, standard corrugated containers, or specialty packaging products, we hope you'll look to Georgia Pacific as your supplier of choice. Safety, sustainability, innovation, quality, customer focus, and value creation. It's in our DNA and everything we do.
Types of industries. In this module, you will learn about the meaning of industries and its types. An industry refers to an economic activity which is concerned with the production of goods, extraction of minerals, and the provision of services. Industries are divided into two major categories, namely primary industries and secondary industries. Primary industries are further classified into two types, namely genetic industries and extractive industries. Similarly, secondary industries are also divided into two more types, namely manufacturing industries and construction industries. Let us understand about each of these types in details. Primary industries produce goods using natural resources. Examples of primary industries include agriculture, fishing, dairy farming, mining, etc. Genetic industries are the types of primary industries which deal with the reproduction of different crops, animals and plants. Examples of genetic industries include horticulture, dairy farming, poultry farming, etc. Extractive industries are the types of primary industries which carry out extraction of different raw materials and ores from the earth. Examples include extraction of ores, drilling of oil wells, etc. Primary industries help in increasing the wealth of nations. Secondary industries are labor-oriented industries and deal with the manufacture of finished products. Manufacturing industries are the types of secondary industries which deal with the conversion of raw materials or semi-finished goods into finished products. Examples of manufacturing industries include making sugar from sugarcane and converting iron ore into steel. Construction industries are also a type of secondary industries which are engaged in construction of canals, roads, bridges, etc. Construction industries help in faster development of economic activities like transportation and communication. Cottage industries are also called as household industries as they are carried out by craftsmen in their own houses. Craftsmen either work with the family members or may take help from apprentices. A person who wants to learn a particular work is called an apprentice. Cottage industries are mainly situated in villages and generate goods for local consumption. Examples of cottage industries include carpentry, smithy, pottery, stone carving, blanket making, etc. Small-scale industries are organized on a small scale at a particular place. However, the goods produced are sold at both the local and the external markets. Small-scale industries use electric power and few machines. They are labor-oriented and also adopt modern techniques. Examples of small-scale industries include manufacturing of shoes, bicycles, soaps, garments, sewing machines, etc. There are some hindrances in transporting goods from producers to consumers. Some of these crucial hindrances include hindrance of place, risk of loss, time, finance, and knowledge. To overcome these hindrances, certain aids have been introduced, which are called as auxiliaries to trade. To overcome the hindrance of place, transportation is used. To overcome the hindrance of finance, banks are established. For covering the risk of loss, insurance companies have come into existence. Storage facilities are used to overcome the hindrance of time, while advertisements help in overcoming the hindrance of knowledge. Let us learn more about each of these aids. Transportation services help in overcoming the hindrances of place. There are four major modes of transportation, namely road transport, railways, water transport, and air transport. Transportation helps to reach the products from producer to the traders and from traders to the consumers. Adequate finance is always needed in the distribution of goods from producers to the consumers. Money is required at every stage for smooth sailing of the business, and this requirement is fulfilled by the banks. Banks provide finance to the traders and help with the smooth conduction of business. There is always a certain amount of risk of damage or destruction involved while transporting and storing goods. To protect traders from such risks, insurance companies have been set up. They insure the goods in terms of money. Any losses incurred by fire or water or any other natural calamities are thus covered by the insurance companies. There is always a time difference between the production of goods and their consumption. During this time gap, the goods need to be stored safely. For this purpose, warehouses have been constructed. Warehouses store these goods till the time of sale. Some warehouses require cold storage facilities, while some are scientifically constructed to allow the storage of specialized goods. Before buying any product, consumers must have a complete knowledge about that product. When a new product is launched into the market, consumers should be made aware about its usefulness. Knowledge about the alternate products must also be given to consumers. Advertising services play a vital role in overcoming the hindrance of knowledge. Let us now recap all the important points that we have covered in this module on the types of industries.
lesson, we are going to see about the industries of India. Before getting started, do not forget to subscribe to our channel to get regular updates. So, let's get started. Primary industries. These industries uses the natural raw material as its final product. For example, hunting, pastoral activities, fishing, forestry, agriculture, etc. Secondary industries. It makes the complex product using the material obtained from the primary industry. For example, steel is used in automobiles and railway engines, while the wooden pulp is used for rayon. Secondary industry can be subclassified into heavy industries and light industries. Territory industry. It is not a branch of manufacturing sector, but it sells the product of the primary and secondary industries via transportation, trading, wholesale, and retailing. Basically, it includes service providers. For example, tourism, education, entertainment, advertisement, consultancy, administration, healthcare, etc. The various factors that are responsible for the location of the industries are availability of raw material, power resources, availability of water, labor, transportation, market, capital resources, and government policies. Indian industries. The agro-based industries totally contribute approximately 17.32% to Indian GDP. Cotton industries. It provides work to the large segment of the population and it can be started with low investment. It helps to earn additional income for the local people. They use the local raw material, which means that the optimum utilization of the natural resources is ensured. It generates seasonal as well as perennial employment for the labor. They play a significant role in our national economy. Timber industry. The timber industry derives its raw material from the bamboo and softwood. It can be found in south of Gujarat, Odisha and Madhya Pradesh. The major sector of the market is located in Calcutta, which brings the raw material from the northeastern states, which has cheap labor, coal, water available. Lucknow is also a major sector and it depends on the baggage from sugar mills, rags, wheat bran and sabai grass which is bought from the tribe region. Cotton and textile industry. Cotton as a raw material is lightweight and non-perishable. When cotton is changed to yarn or textile, it hardly incurs any weight loss. Therefore, the proximity to raw material site is not essential. The factors that become more important in the industrial location will nearness to market, nearness to the water body for dyeing and bleaching, energy to run the power looms and textile machines, cheap labor supply, and availability of capital or finance. In dry climate, the cotton threads will break quickly during spinning, so the cotton textile will set up near the coastal areas. The major cotton industry in India is located in Mumbai, Ahmedabad, and Coimbatore. Silk industry. India has the vast labor and market to match the silk farming. India grows all the important varieties of silk that is mulberry, tussar, oak tussar, eri and muga. Mulberry silk is mainly grown in the southern states such as Karnataka, Tamil Nadu, Andhra Pradesh, but it is also grown in West Bengal and Jammu and Kashmir. The other silks are grown in Jharkhand, Chhattisgarh, Orissa and Northeast. Jute industry. 90% of the jute is cultivated in the Kolkata hinterland. Jute is the only crop that can withstand the flooding of this region. Jute processing requires the large quantity of water for washing, bleaching and retting. The water is easily available from the Hooghly River. Jute processing is labor intensive. The cheap labor availability from Bihar, Odisha and West Bengal is an important factor. Sugar industry. The nature of raw material. Sugar mills are located near the sugar growing areas because of the two important factors. Perishability. Sugarcane contains sucrose and once you cut the sugarcane, the sucrose content starts to decline. Hence, the raw material must be quickly transported. Weight loss. The sugar counts for only 10% of the bulky sugarcane and therefore it is prohibitively expensive to transport sugarcane over the long distance in its original form. Sugar mill. The major raw material that is required for the input is sugarcane. Sugarcane is crushed between the rollers and it makes the sugar juice. The sugar juice plus lime and boiling is the crystallization of the sugar. From coarse brown sugar needs further refining. The bagasse is used as a fodder, energy fuel and in paper pulp industry. Molasses is used to produce the ethanol. The sugar industry is located in the Uttar Pradesh, Maharashtra, south of Gujarat, Karnataka, Tamil Nadu and Andhra Pradesh. Tea plantation industry. Labor availability, weeding, manure, pruning and plucking is a tedious job and it requires skill and patience. The cheap labor force is essential. Since tea has to be grown in the hill slopes, mechanization is not possible. Even while drying, rolling, fermentation, grading and packaging of the tea, skilled manpower is needed. Therefore, tea plantation is done near areas with high population density. Raw material, tea leaves to tea involves a considerable weight loss, hence tea tree processing is done in the estate or plantation itself. The further blending and repacking could be done at the break of the plantation. Frost damages the leaves and very long winter retards the plant growth and hence decreases the yield. Hence, the tea plantations are done in the warmer areas. Topography. It doesn't like the stagnant water, hence it has to be grown on the highland or the hill slopes. For example, the hills of Darjeeling, Jalpaiguri and Nilgiri in Tamil Nadu. With this, we have come to the end of this session. In the next lesson, we would be seeing about the other industry sectors.
subscribe to our channel and click on the bell icon.
Hello friends, I'm Nepali Shah from ExamNet. In this lesson, we are going to see about the industries of India part 2. In the previous lesson, we have seen about the industries of area which was focused on the primary sectors. If you have not watched the previous lesson, do watch that first and then continue with this lesson. The link is given in the description. So, let's get started. What is secondary sector? Manufacturing and industry sector is known as the secondary sector. The secondary sector includes the secondary processing of the raw materials. It is often divided into the heavy industry and light industry. The secondary sector forms a substantial part of the GDP. It creates value goods and it is the engine of the economic growth and is crucial for all the economies. List of manufacturing sector. Iron and steel industry. The location of steel industry is generally oriented to one or the other raw material sources, mainly iron ore or coal. However, the recent technological developments in transport as well as the processing, the use of the scrap as raw material and agglomeration economies make market location, especially coastal areas, advantageous. There are various iron and steel plants located all over the country. Aluminium industry. Aluminium industry in India is one of the leading industries in the Indian economy. The main operations of the Indian aluminium industry is mining of the ores, refining the ore, casting, alloying sheet and rolling it into the furnace. India is the sixth largest producer of bauxite and ninth largest producer of the aluminium ore. Locational factors. Unlike the raw material oriented industry, bauxite is the basic raw material in the aluminium manufacturing process. Bauxite is converted into the aluminium and aluminium refineries. Due to the high quality of bauxite and close proximity between the bauxite mines and aluminium refineries, the cost of bauxite to Indian producers is much more than that of the global producer. The reduction of bauxite into the aluminium requires heavy amount of energy. Therefore, besides the nearest to the bauxite deposits, cheap availability of the power is a major consideration in the location of this industry. The major production centers of aluminium are Korba, Renupur, Belgaum, Alua, Medur, Ratnagiri, and Nalpur. Petrochemical industry. Petrochemical industry is one of the fastest growing industries of India. This industry has revolutionized the industrial chain by providing the products which are substituting the traditional raw materials like wood, glass, and metals. India is self-sufficient in the production of petrochemicals. Petrochemicals are derived from petroleum or natural gas. We use a variety of products from morning till evening made of various petrochemical products such as crayons, detergents, dyes, fertilizers, perfumes, bags, etc. Location pattern. The location pattern of existing as well as those proposed clearly indicate that the refineries seek mostly seaboard location to meet the advantages of the imported crude or the crude produced by the offshore oil field. The other trend is that the raw material is based on the inland oil field. The government policy has played an important role in the setting up of a certain market-based refineries like Gujarat. Fertilizer industry. The fertility of the soil is the most important factor in the agriculture. It depends upon the phosphorus, potassium, nitrogen, calcium, magnesium, sulfur, and other components in proper amounts. Phosphorus, potassium, and nitrogen are the principal elements in the fertilizer industry, which is an important branch of the chemical industry. The fertilizer manufacture is chiefly dependent on the three principal raw materials such as phosphate, potash, and nitrogen. Nitrogen provides the vital fuels for plants and sustenance for the human life. Localization and distribution. The localization and fertilizer industry is closely related to the petrochemical. About 70% of the plants producing nitrogen fertilizer use naphtha as the basic raw material. Phosphatic fertilizer plants are primarily dependent on mineral phosphate, which is available in Uttar Pradesh, Madhya Pradesh, and Rajasthan. Sulfur is another important mineral used for the manufacturing of fertilizers. It is available in Tamil Nadu. Gujarat is one of the largest producers of the fertilizers in India and accounts for more than one-fourth of the total production of nitrogenous as well as the phosphate fertilizers in the country. Drugs and pharmaceutical industry. The pharmaceutical industry is one of the oldest in India. The Indian pharmaceutical industry is at the top of the chart amongst the Indian science-based industries industry with the wide-ranging capabilities in the complex field of the drug manufacturing and technology. The drugs and the pharmaceutical units are mostly located in Kolkata, Mumbai, Ahmedabad, Vadodara, Delhi, Pune, Rishikesh, Hyderabad, Kanpur, Indore, and Jaipur. It ranges from simple headache pills to sophisticated antibiotics and complex cardiac compounds. Almost every type of medicine is now made up by the Indian pharmaceutical industry. Cement industry. Manufacturing of cement requires heavy, low-value, and weight-using materials and is primarily a raw material-oriented industry. The availability of the raw materials, bulk transfer facilities at the reasonably low cost, and the location nearness to the market are the three main localization factors which favor the growth of the cement industry in India. On an average, 1.5 tons of limestone are required to produce 1 ton of the cement. Hence, the location of a cement plant is based on the limestone deposits. The other raw materials used are seashells, slag from steel plants, and slag from fertilizer plants. And these raw materials influence the localization of the cement industry in their own way. Distribution of the cement industry. India ranks second in the world, next only to the China in the production of the cement. It is because of the constraint of the raw material that 86% of the factories and 75% of the production capacity is found in Madhya Pradesh, Chhattisgarh, Andhra Pradesh, Rajasthan, Gujarat, Tamil Nadu, Karnataka, and Bihar.
Throughout the day, we use, dispose, and come into contact with volumes of paper, justifying the thought that a world devoid of paper is inconceivable. More than 18 lakh tons of paper are produced in India every year. The output of this industry is valued at approximately 27,000 million rupees annually. This paper mill is located close to Pune city in Maharashtra. Approximately 22,000 tons of paper is produced here every year. But the story of this paper mill has more to it than just its volume of production. The most obvious link between the paper industry and the environment is its perceived threat to the forest cover. However, another serious threat is the effluents that are discharged by this industry. Highly toxic, it mostly finds its way into the groundwater of adjoining areas. About 6,000 cubic meters of effluent is generated by this paper mill every day. Naturally, it has to be disposed of. Earlier, the factory had a conventional aerobic treatment plant, which used bacteria to clean the wastewater. But aerobic treatment was found to be highly energy intensive. It consumed almost 2 million rupees worth of electricity in a year, eating into the profits of the paper mill. Now, much of the treatment is done by the new plant, which uses the anaerobic digestion process and also generates biogas as a byproduct. The energy bills of the paper mill have reduced by half, and the biogas has substituted about 15% of the mill's fuel requirements. The leftover waste sludge is used to make paperboards for containers. The clean water is then let off into nearby agricultural fields. The Indian paper industry consumes fuel worth approximately 5,600 million rupees in a year, which forms about 20% of the value of their output. It is a major financial burden, but there are successful examples like this paper mill. Along with tough environmental legislation, other paper mills can be motivated to turn energy efficient and eco-friendly.